Alright, hello and welcome back to a little tutorial on how to use our importer here now instead of the exporter. So if you haven't actually seen the exporter video, that'll be kind of needed at this point in time, as the only way to actually import a robot is to first export a robot from CAD. But eventually we'll have a system to where you can simply just take, like, for example, this default bot here and then be able to just raise up or change different aspects of this robot, so you don't have to go through basically the middleman of using a CAD software. But for right now, you will have to do that first video, which you should have seen through this guide here, importing CAD files, which will kind of show you how to do that. And now we're on configure a robot. Alright, so we're starting with this very simple robot here, just to kind of quickly go through it here. So you can see that you can change the color of it. You'll be able to change your team number in case you have a specific team number that you want here. And of course, to display the team numbers, you'll click these displays here and then just click them onto the robot just like that. That looks pretty cool. You can set the weight of the robot. I actually don't know how much this would weigh in real life, but you can still select that. Now for these wheels here, I actually want to set them to Mecanum wheels because then they'll allow me to strafe and do other things. Looks like the axis offset is set correctly. If it's not, then you can of course change it to make sure that the wheels are sitting properly. You can also flip them to be the other way around. And I think the colors are good for both the primary and secondary color of these wheels. And of course, moving swiftly on, I didn't expect to go that fast, through to the second section for the motors here. You can see I already have some things set up here, but you have motor 0, which will be the front left wheel. And I just have it as a Torquedo, just a normal gearbox ratio here. You can see that you can also set it to different motors here as well, which then you'll be able to select different things. And then based off of that, it'll set these important values here of the encoder count, the motor speed, and the torque. So then it'll work properly in the simulator to accurately simulate that physics. Of course, we can test the power here of it spinning, and of course to actually select the wheel here, I'll just kind of reset it here. You can click add component and then click on that specific wheel, and then it will add that joint that's connected to there. And also show this for the slide here. You can see that it actually has two of them here, so let me just kind of reset that, and you can see that I can just click here, click that. You can see it's going the wrong way, so I'll just hit reverse. The limits is automatically set to 0 to 15 inches. That actually needs to be changed to inches, not degrees. And the spool radius, essentially what this means is that typically for these linear slides, they work off of a kind of string system which is spooled around this just central motor. And so this is basically the radius of that spool, which will then calculate the proper forces and velocities to apply to this. But of course we also have another component that will move with this system. We don't want this rotation joint, we just want the linear joint, and we want it going the other way here. So you can see 0 to 15, 0 to 15, and if we test, it should go all the way up. And there we go. And I'll also of course name it slide really quickly here. And then I'll leave all the other names there. Those are kind of all the same. But now moving on to servos here, you can see we have a claw. And this is basically the same thing. I've actually set some degrees here, and if I open it and then close it, you can see that it's all working properly. This is a Rev Smart Servo set to limited mode, and based off of that, it's able to set the servo speed and torque. Of course, if you're using a custom servo or a custom motor, you should be able to specify the specific properties that this servo motor will run at, and it will respond accordingly. Now, of course, now moving on over to here to sensors, we'll want to add a couple of sensors. I think one that will be very important for us is actually a color sensor. So we'll add a new sensor here. We'll call it a color sensor. You can already see it's kind of shining brightly here. All right, and so now we can simply place this sensor right on the bottom here, and you'll see that it'll line up, and then there'll actually be a little light here, and you can actually turn that off if you wanted for the color sensor here. And then that'll of course change the value to be darker or lighter depending on what you exactly want with that. We'll of course call it color sensor, and we'll save that into there. Moving on to the colliders here. Now, colliders may be an interesting thing to talk about whenever you're thinking of a robot, but for a simulator, it's actually very important. It basically allows these claws here to actually be able to pick up the elements that you have. So of course, we'll start off with one here, and this will be an intake. Let me actually place it first. We'll place this collider right in here, probably like this. we'll want to reset the rotation of it and then probably put it down a bit. So using the Y coordinates here, maybe not that far down, maybe approximately there, I think would be a good area for it to be able to pick up. And so essentially what this means is that if you have an element 1 collider, which if we're going back here and then selecting the field to power play, as this is kind of a power play based robot here, you'll be able to intake the cones into this little section here. So of course we have that, and we'll want to intake. It'll intake probably about 0.5, or I guess we'll add the highest delay here, since we don't want to be constantly intaking, as you'll only be able to store one into there. And this intake will activate whenever the servo of the claw is equal to 1. And so whenever you have the power or the position of the servo set to 1, it'll be able to actually intake that cone into the robot, and it'll store it. And of course, how will we store it? Well, we'll store it with actually the same collider, and you can see it's actually pretty well lined up here. So I think this is all good because it's only going to be storing one. It doesn't need to be in a pile or a stack. Essentially what that means, if I can show it off here, you can see that you can just stack them on. So as you get 1, 2, 3, 4, 5, they'll just stack on like that. Or you can select pile and it'll just kind of pile them in a random order. You can also change the direction that it's stacking, so you can have a sort of a diagonal stack like that if your robot supports it. But for right now, we'll just have it set to 1, and we'll just set it to pile. Doesn't really matter for that. And of course, we do actually want to have the cone leave the robot. So through the same collider, we'll actually have just an output system here. Now right now you can see that it actually has a velocity, so if I click launch, it'll actually just launch it that way. But this isn't actually one of those. It'll just be one that drops it like that. So you can see it'll just place it there. Whenever you then have the claw open to position 0. And so now that should all work according to those logic systems that we have there. And of course, if you do have a velocity, you can actually have a velocity motor here. So for example, if you have, let me just quickly hit save here. If you have this robot here, and you have, actually I can just click it. For this one, we have the ring conveyor, this system here determining whenever the robot will actually outtake one of these cones here. But that speed isn't necessarily determined based off of the conveyor, it's actually based off of these two ring launchers here. So you can see if you hit launch, it'll launch that way, but it's also determined based off of these two motors here. So that was just kind of a quick little thing. Going back to here though, you can see that we have pretty much everything that we need for this collider. Let me actually name it the Cone Collider to make it sound kind of ominous, I guess. And there's actually one more thing that I kind of forgot to do, is to actually select the anchor. Because right now, whenever this slide goes up and down, the position of this collider won't actually move with it. Instead, you can see that it's kind of just anchored onto the bottom here. So if I click select component and then select component to this lastmost slide here, this collider will now move with that slide. So I think that's all actually good, so we can go over to test here. Alright, so now we can see that we can actually change it to Mecanum Drive here, and it will automatically kind of link it up to WASD and then also Q and E to rotate here, based off of just the motors of the wheels that we have here. We have motor 4, which is this slide here, and we can see that it's actually toggled, so if you press 5, it'll go all the way up, which you'll see some data for in here. You can see the power, the velocity, and the position. If I hit 5 again, it'll lower. Let's actually see the collider here, and you can see if I press 5, the collider will move up with it. And if I just go ahead and just automatically place one in here, you can see that a cone is now in the collider. But of course it just dropped out because we don't actually have the claws activated. So if we go over to the servos here, you can see that the servos are activated by pressing 0. So you can see that the position is 0 whenever it's closed and 1 whenever it's open. So you can see like this. So we'll actually want to switch over in the colliders here. What will activate the intake and what will activate not the intake, essentially. So we go into that, we just quickly change that, and now this should work accordingly. So whenever it's open and whenever it's closed, it'll do that. Let's of course just spawn one in and we can test it. So it's open right now, we go into it and then we press 0 to close onto it. You can see that's now closed onto it properly. And it'll lift it all the way up. But then once we hit 0 and we let go of it, it'll also drop the cone. and then everything should be working for the robot. You can move around, you can test different things, and you'll just be able to score and use your actual CADed robot in the actual software of the Virtual Robot Simulator. But hopefully I provided all of the info, and if you have any concerns, any issues, or just want to talk about anything that we could add to the simulator to make it even better, be sure to let us know, and we will get straight to that. But thank you for watching, and hopefully this helps you on your robot simulator journey.